H1 VM3, 5.2.1. So, quick show of hands. I know someone did this earlier, but I'll do the same thing. All those people who have read VM3, 5.2.1, raise their hands. Sweet, 4. All those people who think they could articulate that particular part of New Zealand's building code to the person next to them. Yeah, and I guess that's the issue, eh? VM3 5.2.1, the regulation implemented in November 2021 says that we've all got to insulate ducting in commercial buildings over 300 metres, and across the country I speak to a lot of people that aren't aware of what the code is and what it means for us, so I thought in a very short space of 7 seconds, so that would be quick, wouldn't it? In a short space of 7 minutes, I'll try and give a bit of an overview as to what it means and what a way of achieving it might be. So, notes, because I'm no expert either. Some notes on 5.2.1. It's a pretty dry topic, to be fair, so 7 minutes is probably enough. It was implemented in November 2021, so if you're doing a commercial building that's got a new consent at that time, you need to be comply to it. If it's a commercial building over 300 square metres. In terms of insulation of duct, the flex is really easy. You've got to be R1. Most people can comply with that. However, the rigid duct, which is what we're primarily going to talk about tonight, is somewhat more complex. This is a section of the code. You can see this first line here says if you're in an air-conditioned space, you've got to have an R rating of 1.2 on your rigid duct. So if there was a room out there that had air-conditioned air in it, and there was a duct running through this one to another room out the other end, and this was an air-conditioned space, all your ducts got to be 1.2. If you're going through an area where you're exposed to direct sunlight, like duct going across the roof of a building, your R rating needs to be R3. And if you're going through any other locations, which I guess would be unconditioned space, like maybe a car park or a warehouse or something like that, where you're not running AC, you've got to be R2. So, what does that mean for us, supplying the duct? It means a whole bunch of things. One, there's a whole bunch of additional cost. If you're using galv duct and you're putting insulation on it, to get R1.2, you've got to have a duct wrap of about 50 mil. If you're going R2, it gets up to about 75. If you've got R3 requirements, then it's about 115 mils of duct wrap around your galv ducting. So there's a huge amount more weight in installing that. Obviously, if it's R2, which is quite a common situation in a commercial building, you're now 75 mils on each side of a rectangular duct, so you're now 150 mil bigger. And I've yet to meet an installer that says, my goodness, there's so much space in this roof cavity with these new rules. Doesn't seem to be much insulation around it. I haven't banged my head yet. We all know that doesn't happen because the spaces are getting smaller and we don't have as much room to put our duct in as what we used to. Freight costs are higher, health and safety issues on site, lifting heavy duct into place is a lot more difficult. And the other thing I have yet to find, and there may be one here tonight, please put your hand up, is somebody who would like to spend the rest of their career up in ceiling cavities, wrapping galv duct in insulation. Yeah, no one wants to do that, eh? Because it's a horrible job. So, my thinking is, perhaps we're doing this all wrong. Rather than getting galv duct and getting a product which has got no insulation properties at all and try to give it insulation properties, why don't we start with a product that's already got some insulation properties and build our H1 VM3 5.2.1 ducting out of that. So, I went for smooth air, so I brought along a smooth air product. Imagine this product, which is a PIR duct, is 4 metres long, and instead of being 400 wide, it's 600 wide. There's some going out of the factory the other day, it's 4 metres long. It weighs about 1/8 as much as if you were to wrap galv duct. So all your installation issues in terms of weight, freight, health and safety, all the gripples to hold it and seismic bracing and all that stuff is reduced to an eighth if you were using galv duct. Massive savings. Cost to build that compared to an insulated galv duct is about the same. So material costs about the same, cost to install way down. A much better solution than wrapping galv duct. I say that with my tongue in my cheek because as a company we make quite a lot of money out of wrapping galv duct, but I think that's probably a better product. We have this same product, it's called PIR, you've probably seen it, we've been installing it for about 15 years. This particular product is called TD panel. We have this in 3 different thicknesses. So we have our 1.2. So we have it in a thickness for our 1.2, we have it in a thickness for R3, and we have it in a thickness for R2. Did I get that right? 1.2, 2 and 3. Anyway, 3 thicknesses. It's about half the gauge of wrap duct. So this is 42 mil thick, whereas if you get galv duct and you wrap it, it's about 75. Bit of a no-brainer. I know what you're thinking, wow, this guy's onto it. So, bit of a summary. H1 VM3 5.2.1, it's all new consent since November. It's quite poorly understood, and around the country I see a reasonable amount of non-compliance on commercial sites. Produces some significant challenges for HVAC designers and also installers. I think the change that we need to make as an industry is going to a rigid duct that's got some inbuilt insulation. So trying to fix up something that got no insulation properties to make it insulated is just dumb. We should be starting with a product that's insulated. And we've got some samples outside, we're probably all shut up there now, but if anyone wants to talk more about that, I'm available after the chat tonight, and I work for Smoothie, and if you want to pick up the phone and talk or come and see us, we'd love to talk to you about our TD panel as an option to wrapping galv duct. Thanks for your time.